Hi class, good morning. Today we're going to talk about acid-base titration. Now titration is a lab process, so it's a little tricky to explain. We were supposed to be doing this in the actual lab, but I'm going to go over the features of an acid-base titration, which is a lab process that helps us figure out the concentration of an unknown acid or the concentration of an unknown base. And it uses the technique of neutralization because we know an acid plus a base is a salt plus water. So as a result, we're going to titrate an acid against an unknown base's molarity. Okay, so here we go. Looking at titration, we want to realize the definition is it's a lab process. It's a laboratory process. It uses neutralization. And the function of it, or the purpose of it, is to calculate the molarity, which remember is solution concentration. Molarity is moles per liter. So calculate the molarity of an unknown acid, which is the hydrogen ion, or base, which is the hydroxide ion. In our experiment at Schreiber, it was the base whose concentration is unknown. It was the base. So I'll show you the setup really quick. But I want you to remember that a hydrogen ion comes in contact with a hydroxide ion. Collisions, collisions, collisions. This is according to the Arrhenius theory, making H plus OH minus. So this is the net equation for neutralization. The net equation for neutralization which we know brings us to a pH of 7. Now just as a reverb, Kw is equal to 1.0 times 10 to the negative 14. So if you're at a pH equal to 7, your hydrogen ion concentration is 1.0 times 10 to the negative 7. So now we want to realize that the hydroxide ion concentration is 1.0 times 10 to the negative 7. Molar. Okay? So, just to repeat, titration is a lab process. It uses neutralization. So we're going to react an acid and a base. Well, what is our purpose? Our purpose is to calculate the molarity of an unknown acid or base. We have to realize in our experiment, it's the base that we're seeking. So hydrogen ion plus hydroxide ion yields HOH. And that is the net equation for neutralization. And this is a little blast from the past here about the Kw and the pH. Now you have to realize something. You have acid going into base. Okay? So if you have acid going into base, you're making a salt plus water. We need to know when does that neutralization occur. So in order for us to know it, we need an indicator. So remember, an indicator is a substance that changes color in a specific pH range. So let's reflect back. Remember the common acid-base indicators? So we know that phenolphthalein, and there's a lot of different pronunciations. I always call it phenolphthalein. It's probably wrong, but it's colorless in an acid and then pink in a base. Those are the general ranges. Colorless in an acid and then pink in a base. Phenolphthalein is the acid-base indicator that we would have used in our titration experiment. So all of these indicators change color in the range of either acid or base. So in general, we know that phenolphthalein is going to be colorless in acid, and then as you're adding base, it's going to go to a pink. And that's going to be the indication that we're in the neutralization point or the end point of the experiment. So the end point of the experiment is when we see a whisper of pink, a very slight pink in the experiment, and that's giving us the idea that the H plus and the OH minus have equaled out, and it's just a little bit over pH 7. So it goes very slightly pink. And there's a virtual lab that will follow this video in terms of the titration experiment. Okay, so we'll end there in terms of what is titration. What are we doing? We are looking for the unknown concentration of a base.